For algebra lesson, this should say, hopefully in yours it says 11.1. If not, I need to fix that. But this is module 11. 11.1 notes is about organizing data using matrices. So why would we need to organize data into a matrix? Let's take a look at this first top example and see what they're saying. Jeff, Tina, and Eric, there we go, it's in focus finally, run a landscaping business. They charge $12 per hour. How much should they bill the Agawas? Explain how you found your answer. So Jeff says on Saturday, the Agawas, he worked 5 hours and then the bakers worked 2. Tina says Sunday she worked the bakers 2 hours and then Agawa's 1 hour. Smith's, Tina 3 hours, Jeff 4 hours, Eric 2 hours, and this was Sunday. There's a lot of information here. So a better way than just writing it all on, it looks like sticky notes, is to make it into a matrix. So a matrix is a rectangular arrangement of numbers into rows. The rows go left to right, as it's pointing out here, and columns. Columns are the ones that go vertically up and down. The plural of matrix, so if we have multiple matrices, it would actually be matrices. The matrix below shows the hours that Jeff, Tina, and then Eric worked on just Saturday. So this matrix is only representing Saturday. Jeff worked 5 hours for the Agawas, 2 for bakers, Tina's information, Eric's information. Okay. This is what a matrix looks like. It's usually in a bracket. This kind of has the edges it's supposed to that are squared off. It's not parentheses, it's a bracket. And like I said earlier, it is organized in rows and columns. You identify the size of a matrix by the number of rows and the number of columns. So this one has 3 rows and 2 columns, so therefore it is a 3 by 2 matrix. Each number in a matrix is considered an element. So 5 is an element, 2 is an element, 3 is an element. Matrices are equal if they are the same size and number of elements correspond are equal. So for example, here's a 2 by 2 matrix, and it says it equals this other 2 by 2 matrix. So, and the only reason we know they are equal is because this first one in the top left is -1, and so is this. The one in the top right is 2, but that is equal to 4 divided by 2. The one in the bottom left is 4, but that is equal to 5 minus 1, and then 0 is equal to 0. So they need to be in the same position, equal to the ones that are in the same position relative to it. Okay, let's turn this over. We are going to be adding and subtracting, and then here in a little bit multiplying matrices. In order to add or subtract, you have to have the same number of elements added with a matrix of the same number of elements. This didn't copy very dark, but that's a negative, and so is that, and so is that. So all you're going to do is add the -5 to the -3. So it's in the same position, it's in the top left corner, so -5 plus -3 is -8. They're just working it out for you here. In the top right corner, 2.7 plus -3.9 is -1.2. So you'd put it in the top right corner. 7 plus -4 is 3. So it goes in that same spot relative to where it was. And then -3 plus 2 is -1. So this is our answer whenever you added these two matrices. Same thing works when you subtract. You look at where the 2 is and you find that same spot where it is in the other one, which is -1, and we are subtracting. Remember that 2 minus -1, that'd be minus and negative right next to each other, becomes plus plus. That would equal 3. 11 minus 8 is 3. -4 minus -6.5 is positive 2.5. 3.2 minus 4 is -0.8. 1.5 minus 0 is 1.5. -5 minus -3 is -2. Okay, so this is the answer when you subtract. This is very simple. You just have to match up the parts and either subtract if there's subtraction between or add if there's adding between. So go ahead and pause the video and try these A and B got it's on your own and see how you do. All right, if you are ready to see the answers, I've already explained how to do this, so I am actually just going to write in the answers for you that you should have gotten. 5 plus -9 is -4. It's in the top 3.2 plus negative 1.7 is positive 1.5. It should be in the middle of the column. And then at the bottom, negative 4.9 plus negative 11.1 is negative 16. All right, when you subtracted this 2 by 2 matrix, you should end with a 2 by 2 matrix because it has to be lined up correctly. You should have gotten 1, then 1, then 2.5, then 10. Double check that I did that right because I didn't actually work it out right here. Okay, letter C says, explain why you cannot add or subtract matrices that are not the same size. That should make sense pretty relatively because you have to match numbers. I'm not sure if this is the exact definition you should put, but you have to match numbers in the same location to be able to add or subtract them. So basically what that means is you can't have the shapes be different because then you'd have a leftover number that you wouldn't know what to do with. Okay, let's move on to multiplication. In order to multiply, you have to have something called a scalar. That's what we're scaling it up by or multiplying it by. So multiplying a matrix by scalar is called scalar multiplication, and that number usually just goes right out front. So if you have a 2 by 2 matrix, 4, negative 1.5, 1, and negative 6, and the scalar out front is a 3, you're basically distributing that 3 to all of the parts of the matrix, and then that is your answer. So 3 times 4 is 12, 3 times negative 1.5 is negative 4.5, 3 times 1 is 3, 3 times negative 6 is negative 18. Again, not very difficult. You probably would be able to figure this out on your own. In fact, I'm ready for you to pause the video and try the 2 on the got it's, and then push play again and see how you did. Okay, I'm just going to write out the answers because I know that by now you guys know how to multiply. Negative 2 times negative 3 is 6. Negative 2 times 7.1, if I did it right, is negative 14.2. And then negative 2 times 5 is negative 10. You do not need commas between, but you really should leave enough space. Mine, I probably should have written a little bit smaller or left a little bit more space because in a matrix, you can tell there's a clear division of where those problems stop or where those numbers stop. And I didn't do a very good job of that. So there's not commas between, but just leave enough space in between that you can tell how it's supposed to go. Okay, last one, 1.5 times all of these would mean it's a 2 by 2 matrix, and the answers should be negative 16.5, 4.5, 0, and then negative 2.25.